This is Mr. Ashton going through the Mathematics Numeracy Unit 2 Calculator Aloud Intermediate Tier paper from the summer of 2017. Okay then, so the first question says, bus timetable from Orme Station to Outlet Village, only 55 minutes from Orme Station to Outlet Village. Buses leave the station every 12 minutes from 8 AM till 12 noon and every 24 minutes from 12 noon till 10 PM. At what time does the first bus after 9 AM leave Orme Station? So it leaves every 12 minutes from 8 AM. So if we count then in 12s, we'd have 8 AM where it would leave, then 8:12, 8:24, 8:36, 8:48, and add 12 onto that would be 9, which isn't one of the options. So then it's going to be 9:12. It's just repeating the 12, so it's 9:12 there. Okay. The next question, part B, says, Gwyll looks at the timetable shown above. He decides to take the latest possible bus to be at the Outlet Village by 3 PM or 1500. What time will he arrive at the Outlet Village? So he wants to take the latest one. It tells us here that it takes 55 minutes to get from Orme to the Outlet Village. Okay, so if I want to get there by 1500, then I need to come back 55 minutes. So if I come back 55 minutes here, let me just make sure you can see what I'm doing. Take away 55 minutes off that. That would have us still on 2 PM, and then it would be 14:05. Take off 50, then take off 5 minutes, would put us on 14:05. So then we know that from 12 noon, they leave every 24 minutes. So what I'm going to do is work from 12 noon, I'm going to add 24 minutes, and then make sure that I've caught the bus by 14:05. So 12 noon, and then it's going to be 12:24, 12:48, then add 12 to take us up to 13, then another 12 to make it a 24-minute journey, so 13:12. Add 12 to that would be 13:36. Add 24 to that. Add 24 to that would take me to 1400. And then if I left it any later, it'd be 14:24. And that would be too late because I need to get on that at the very latest. So it would be this bus here. And it would then take 55 minutes. So Gwyll would arrive at 14:55 to make sure he's there by 3. Okay, next question says, Luigi lives in South Wales, Rosina lives in West Wales. For the first 65 days of 2017, they recorded whether or not it had rained. Luigi recorded that it rained on 28 of these days. Rosina recorded that it had rained on 40% of these 65 days. Luigi says for the first 65 days of 2017, with rain where I live and where Rosina lives. Is Luigi correct? You must show all your working. Well, the problem is they've recorded it in different ways. Luigi is just saying that it did 28 out of 65. So 28 out of 65 days, that would be as a fraction. And then Rosina has done it as a percentage. She said it's 40%, which is obviously as a percentage. Okay, so we've got two things that we could do. We could either turn that into a percentage and then compare them, or we could go and find out what 40% of 65 is, which is probably the easiest way to do that. So to do that, I'm going to do 40%, so 14 out of 100, and times it by 65, which is the amount of days that they did it. So it was 40% of those days. Times by 65 gives me an answer of 26 days rain. So 26 days belonged to 40%. So it's this one here which belonged to Rosina. So Luigi said there were more days that rain where I live. So Luigi is correct, okay, because it's only 26 days. So I'm going to say, yes, correct, as Luigi had 28 days of rain compared to 26. Okay, next question. So next question says, Thomas is looking at gym memberships for Haddon's Gym and the Workout Palace. Each of these gyms displays its membership in a pie chart. So women, children, men, women. Okay. We're then asked to about what percentage of Haddon's gym, so Haddon's gym, which is this one, are children. So we want to know what percentage that is that are children. So now you do need an angle measure to do that. So I've got a 360 one that I use. So if I come and read off my angle here, you'll see that that line doesn't actually cross anything there, which is an issue. So what I need to do is I need to extend that line so it will cross my protractor. I'm just doing that by using a ruler. And then I'm going to come off and read it properly. So I make that, I think I make it 76 degrees. So that would be 76 degrees out of 360 times by 100 to change it into a percentage. Equals, and I get 21 and a bit, so the closest answer there would be 20%. I'm then asked here, which of the following is the best estimate for percentage of members of Workout Palace who are women? So again, very similar idea here. I need to go and measure that angle. So again, I'm going to extend the line here so it will cut my protractor. Make sure 0 goes on that line there. I line up the protractor, the middle point on the dot. Make sure that line's perfect. Make sure that's perfectly on the dot. And I measure that to be 136 degrees. So 136 degrees is going to go there. So that would be 136 degrees out of 360 times by 100. So 136 out of 360 times by 100 comes to 37.7 recurring by the looks of it. So which one is that closest to? 38%. Okay. Then says part C. Just make sure you can see it. Thomas says there are more men with membership in Haddon's gym than Workout Palace. Is Thomas certain to be correct? Now the key word there is in bold. Is he certain to be correct? So I can already tell you the answer. Even though the men piece of the pie chart here in Haddon's gym is bigger than the piece of the pie chart here in Workout Palace, we're not told how many people here. If there are literally 10 people here, and then like 1,000 people here, then that would represent more people, because that's what, nearly half of the pie chart's about 500, whereas that's nearly half, but if 10 people would be 5, so is this one would be bigger if that was the case. Okay, so we cannot be certain just because the pie chart shows a bigger chunk. Okay, so no. So I'm going to say these are proportions as my answer. These are proportions, and we are not told how many people. Okay, quite a nice question they like to ask, so be wary of that for the future. Okay, over the page we're given a scatter graph, and it says describe the correlation of the scatter graph or the scatter diagram. Well, the scatters are everywhere. There's no pattern. It's not like they're going in a diagonal going up. It's not like they're in a diagonal coming down. They're just scattered everywhere, so we call that no correlation. Okay, so no correlation is the answer for that. It then says part B, the friends noticed that the tallest pet, well, we haven't even read the question first of all. It says a group of friends measured their heights and masses of their pets. The scatter diagram shows the results. Okay, it then says the friends noticed that the tallest pet has the same mass as another pet. What is the height of this pet? Okay, so we need to go and find the tallest pet. So I'm looking at the height axes here, and then the biggest one there. So this one has the biggest height, and we're told that the tallest pet has the same mass. So the same mass is 30 as this pet here, which is bang in the middle of 50 and 60. So that would be 55. So 55 goes there. Okay. Question 5. Just move the camera a bit so you can see what I'm doing. It says Glenda plans to drive from Flint to Cardiff. On a long journey, her average speed is usually 42 miles per hour. Last time she drove from Flint to Cardiff, it took her 3.5 hours. Use this information to calculate the distance between Flint and Cardiff. The first thing I'm going to do to try and help me work it out is use the triangle, the speed, distance, time triangle. So speed is equal to distance over time. We're then told this thing here, which is equal to a speed. We're told this thing here, which is equal to a time, 3.5 hours. So I'm looking for distance. So to work out distance, I cover up D. So I do speed times time. So the distance, d, is equal to the speed, 42 miles per hour, times by the time, which is 3.5 hours. So I'd write that's 3.5 hours. Now just check that unit there and that unit there are the same. Hours and hours, they are. So I can literally just put that into my calculator. 42 times 3.5, which comes to 147. And because it was miles per hour and I did it 3.5 hours, it would be 147 miles. Okay. Now, we're then asked to give a possible reason why your answer in A is only an estimate for the distance between Flint and Cardiff. Well, in terms of how long it takes, if there's traffic on the road, it could slow you down. That means that your speed will probably change in terms of that. But in terms of what you're doing, it's going to make that time take longer. And if she usually drives at 42 miles an hour, if that took longer with the traffic, then it's only an estimate. Okay, so traffic on the road could be different. Okay. Next question says Gustav is making some scones for his sister's birthday. Here's the recipe for 12 scones. How much self-raising flour will Gustav need to make 30 scones? So there's the question. We've gone from 12 up to 30. Okay. Now, I need to make this recipe bigger. I need to make it 12 times something to get 30. Okay, so 12 times something equals 30. Well, to find out what that something is, I'm going to divide both of those sides by 12. To find out the something that I times it by is 30 divided by 12, which is 2.5. So basically, I need to multiply this recipe by 2.5 to find out what it would be for 30. So if I'm asked how much self-raising flour, I go into the recipe, find the self-raising flour, which is the first entry, which is 450. So it would be 450 times by 2.5 to get 1,125. So hopefully that's an option. There we go. So 450 times by 2.5. Other ways you could do it, double the amount of scones would be 24. So you double the amount of self-raising flour. Half the amount of scones would be 6. So half of that would be 225. And then 6 scones add 24 scones would be 30 scones. 225 plus 900 is 1,225. We're also told then that in the recipe, the temperature of the oven is given in Fahrenheit. The temperature gauge on Gustav's oven is in Celsius. Use the formula to convert Fahrenheit into Celsius. So we're told 5F, which means 5 times F. We're told that his F here is 428, so that'll get substituted into that, okay? So we just need to know that if a number is touching a letter, that means it's timesing by it. And I always write it in with brackets. So I'm going to say 5 brackets, 428, close my brackets, take away 160, all divided by 9 will give me the answer in degrees Celsius. So if I just move the camera there, you'll see the answer when I put it in now. So I'm going to press the fraction button, 5, 428, close your bracket, take away 160, divided by 9, comes to 220 degrees Celsius. Okay then, next question. It says, Gustav makes a birthday cake for his sister. The top face is the shape of a trapezium. Now, you're told what the area of a trapezium is on your formula sheet. It's this formula here, a half A plus BH. A plus B in brackets, they are the parallel sides. In fact, it looks exactly the same as that in all honesty. And H is at right angles, so we know those things there. So I can go and write here A, B, and H if I need to use the formula, okay? What are we told then? We're told that Gustav plans to ice the top face of his cake. Each packet of icing costs £1.35 and covers 65 centimetres squared. So we are told an area, okay? Calculate the area of the top face that Gustav has made. So we need to do area is equal to a half A plus B H. That's from the formula booklet. Now that then I would substitute in as a half 15 plus 20, close brackets, touching the brackets means timesing, put the times in now if I'm putting numbers in, not letters, times by 12, and then that goes into my calculator as it looks there. So a half, over to the side, brackets, 15 plus 20, close brackets, times by 12, equals 210 centimetres squared. We're then asked to show how much it will cost Gustav to make to ice the top face of his cake. Well, we know that 65 centimetres squared is equal to £1.35. We're told that above. That each packet here costs £1.35 and covers 65 centimetres squared. I've got to get that up to 210. So if I double the amount of icing, that would be 130 centimetres squared. That would be double the price. So that would be £2.70. If I added 65 onto that, that would be 195, which still comes short. So I'm just going to say there that's one packet. This was 2 packets. It was twice as much. We know that 3 will still be short. So if I double that again, it would be 260 centimetres squared, which would be 4 packets. That would be double the cost again. So 2 packets. And it says how much will Gustav cost. So there we go. I've actually answered it. So the cost that Gustav would make is £5.40. And it's because you'd need 4 packets, which would cover that much. You'd have a little bit of spare icing as well. We're then asked as well, it says, Gustav plans to decorate the cake with small pieces of marzipan shaped as shown below. Let me make sure you can see the space at the bottom of the page. The top face will each have marzipan pieces that is a rhombus like that. Will these pieces of marzipan tessellate? Yes or no? Draw a simple diagram to represent your answer. So tessellate just means they all fit together. Rhombuses do tessellate. And the diagram to show my answer, I'm just going to draw them in straight away, I think. So be something like that, where your rhombuses then would just repeat and repeat and repeat. So I'm just going to draw that as parallel to there. That would be parallel to there, and so on and so on and so on. Okay, so here you can see that I've got a number of those rhombuses tessellating already. Okay, so that's what it means to tessellate. They all fit together and they join together with no angles missing. Over the page, we're told that Alan has made his own conversion graph to change knots into miles per hour. Miles per hour on the left, not on the left, sorry, on the left side of the page, but on the y-axis, and knots on the x-axis. Used Alan's conversion graph to write 150 knots in miles per hour. So the first thing I'm going to do is get my pencil. I'm going to make sure it's sharp. If you haven't, that's just great. Okay, I'll use a different pencil. I've got another one there. So 150 would be bang in the middle between 100 and 200. And then I'm going to come off and read off here. Now I can see it's in the middle of 115 and 230. So what I'm going to do is work that out by using, by adding them together and then dividing it by 2. Now there's a couple of different ways you could do this, but that for me is the easiest way to find what's in the middle of 2 numbers. So if I press the fraction button and do 115, add 230, and then divide that by 2, I get the answer 172.5 miles per hour. Okay. Another way to do it is to go and work out what 1 square is. To do that, you say, how much is this jump here? So from 0 to 115 is 115. Divide that by the number of small squares in the jump. So divide that by 20. 10 there and another 10 make 20. So 115 divided by 20 tells me that each square is worth 5.75. Now this is 10 little squares up from that. So if I do 5.75 times by 10, that tells me that 1 square, 1 big square that is worth 57.5. So that would be 115 plus 57.5. And then if I add 115 to 57.5, I get what I just had, 172.5 miles per hour. Okay. We're then told on part B, Nikita thinks Alan's conversion graph may be inaccurate. She knows that 1,000 knots is 1,150.779 miles per hour corrected 3 decimal places. Convert 20 knots to miles per hour using Alan's time graph and then using Nikita's values. So let's go and do Alan's first of all. So we need to go and do 20 knots into miles per hour. So knots, we're looking for 20. So we need to go and work out where that would be. So we know here, use the sharp pencil, is 50. So that is a jump of 50 with 10 little squares. So 50 divided by 10 would be 5. So each little square is worth 5. So 5, 10, 15, 20. I would go up, hit the graph, which is on the 4th square there as well, and read off. So I needed to know what each little square was. So that is going to be 4 lots I'm going to write that down here now, okay? 4 lots of 5.75. That's what 1 square is. That's what I worked out before. So 4 times by 5.75 comes to 23 miles per hour. I'll just say here using using conversion graph. And now I'm going to work out what Nikita's is. So I'm going to do that by writing the following. Literally going to write what she said in the sentence, but looking more mathematical by saying 1,000 knots is equal to 1150.779 miles per hour. I want to change that to 20 knots. So I need to find what I've divided 1,000 by to get 20. Now, if I do 1,000 divided by 20, I'll work out how many 20s fit into that. Sorry, 1,000 divided by 20 comes to 50. So that is effectively 20 times by 50 will give me 1,000. So I want to do 1,000 divided by 50 to get 20 knots. If you were unsure, another way to do it is to divide both sides by 1,000. That would give you what 1 knot is, and then times both sides by 20, okay? But I'm going to stick with the dividing both sides by 50. And then I want to do 1,150.779 divided by 50, and that comes to 23. Now, it says to give my answer. So I'll write the whole thing first, and then I'll round it in case I do make any errors. It's a good tip to use in the exam. So I'm going to say 20 knots is equal to 23.02 miles per hour. We're then asked to work out the difference. 3.02 take away 23, so that is a difference of 0.02 miles per hour. Calculate the difference. So that's all I've been asked. I've not been asked to show any opinion, but she said his conversion graph was inaccurate. I disagree if there's only 0.02 miles per hour out. Okay then, the next question says, number 8, Miss Rashid gave her Year 9 French class a test on Wednesday. She asked the class to spell 12 different words. She displays the results as shown below. How many people scored more than 9? Now the key word is bolded there, is more than 9, so I'm only after this bar here and this bar here. So I need to go and read off that graph again. Now if that's 5 here, that is a jump of 5. With 10 little squares. 5 divided by 10, be careful, it's 0.5, it's not 2, that's the common wrong answer there. So each square is worth half person, half pupil, so that is 1, and then, I can't even count here, 1, 2, 3, so there's 3 in this bar here, and then there's 2 in this bar here. So how many people scored more than 9? 3 and 2 make a grand total of 5. We're then asked how many pupils there are in Miss Rashid's class. So let's go and work out here that we've got 5, 1 person there, 2 people there, 2 people there. That's 10. That's 15. So the middle is 12.5, and we know that one little square is 0.5. So 12.5 add 0.5 would be 13. So we need to add together 1 and 5 and 2 and 2 and later adding them, and you'll find out that it's 28. I'm then asked, what assumption have I made? Well, there's certainly 28 people here who took the test. I've answered here how many pupils there are in her class. So I'm going to say that everyone was in. Okay, everyone was present in the lesson. Okay. We're then asked, I won't quite hide that one yet in case I need it again. We're then asked, Leon says, by looking at the Year 10 graph, I think there is very little difference between the mode and the mean of these scores. Without calculating the mean, explain whether Leon is correct or not. Well, if we looked at these things here, we've got, so what's he said? He said between the mode, very little difference between the mode and the median. No, sorry, the mode and the mean. And the mean is add them all together and divided by how many. You can see that they're quite closely packed together. These guys here, between 12 and 1, but we have the same amount of bars above as we sort of do below there. 8 and 9 are pretty close, so the mode is very little. I've been inclined to agree with him with that sort of distribution here, that you've got a few people there and a few people there above and below. Same about here, 5 here, 5 and 9 here below. These ones here are a bit lower. So I'm going to say most people scored around 8, with roughly the same above and below. Same proportion, should I say. There's obviously less people in that class. Okay. We're then asked, underneath it says, Katrin looks at the two sets of data Miss Rashid displayed. She says, year 10 are better at spelling than year 9. Well, I don't think that is true. That's her year 10 results, and their median was 8. The year 9's median was 9. So I'm going to say she's incorrect. And I'm going to say only median of year 9 is higher. Make sure that you can see what I'm writing there. Median of year 9 is higher than median of year 10. Okay. Okay, next question is a really tricky loci one. You'll need a compass for this question, and I will start talking it through now. It says, Organics for You is planning to have its headquarters in Wales. The manager has instructed Fion to look for a site for the headquarters. Here are the instructions that Fion has been given by her manager. Find the point that is an equal distance between Wrexham and Aberporth. So I'm going to go through these one by one, okay? Here's Aberporth, here's Wrexham. To go and find equal distance, what I do is I open my compass to what is obviously more than half of the distance between the two. Now, that is more than half as far as I'm concerned. And you draw a semicircle from one, keeping it exactly the same width. I haven't touched the compass. Come over to the other place, and you draw a semicircle from there. Okay? Now, where those two semicircles cross, you get your ruler to line up with that, line up with the other one, and you draw a straight line through the two. Okay? Anywhere on that line, it will be the same distance to Aberporth as it will be to Wrexham. Take this point, for example. If I went and measured the distance from Aberporth over to the line, 6.5 centimetres. If I go and measure here, it's 6.5 centimetres. Okay? So, I've dealt with the first one. It then says it has to be within equal distance of Caernarfon and Swansea. So there's Caernarfon, there's Swansea. So we have to do exactly the same thing again. Now, don't rub out any of the lines. They're what we call construction arcs. So you need to just pretend they're not here, okay? But what I am going to do to make it easy for me is turn the page to landscape, okay? So compass there, that is obviously more than halfway to Swansea. I draw an arc, trying to ignore the first arcs that I've drawn. And then I'm going to draw another arc here. So looking at that new arc, I knew I crossed it there. And I crossed it out to see here. Okay, getting my ruler, I line them up. And I draw a nice bold line there. Okay, now anywhere on this bold line is exactly the same distance to Swansea as it is to Caernarfon. Okay, so I've now dealt with that as well. It says the new headquarters need to be within 20 miles of this point. Now, we're told here a scale that 0 to 20 is that distance there. So what I'm going to do now is measure my compass in the scale. Okay, so now those two lines there, where they cross, that's going to be where I put my compass. That is the same distance to Swansea as it is to Caernarfon. That is the same distance to Aberporth as it is to Wrexham. It needs to be within 20 miles of that point. So here, and notice now I'm going to move the whole paper around rather than moving the compass around. I find that's much easier. Okay, so now I've got that circle. Anywhere within that circle is within 20 miles of that point. But he did also say he wants it to be in Wales, didn't he? So I make it anywhere on this circle here, but is within Wales as well. Okay, so I'm not actually going to circle in England. Okay, so anywhere here fits the criteria that we've been given. Okay, question B. We're going to be assessed on the quality of our written communication in this question. Give yourself a minute to read this, and then I'll start going through it. Okay, quite a tricky question, so make sure you're taking time to read it. Okay, it says, Organics for You has 16 vehicles on the road working every day. This company has 6 vans and 10 trucks. Theon has the following information for each type of vehicle. For a van, average distance travelled per litre or kilometre per litre is 8. So for every 8 kilometres travelled, it uses up 1 litre. We're then told the average distance per day, kilometres per day, is 256 kilometres. Okay. We're then told for a truck that the kilometre per litre, so they do less kilometres to use a litre because they're bigger, so they have more effort to use, and they travel a further distance. Okay, now we know that for the vans we have 6 of them, and this is for a van. Okay, we're then asked here. The fuel used by all of the 16 vehicles costs £1.10 per litre. Use this information to calculate the total fuel bill for 1 working day. You must show all your working. Well, what I'm going to do is work out what the van is, that I know that for every 8 kilometres, 1 litre is used. Okay. What's in the table? 256, so I'll squeeze the 5 in there, 256 kilometres per day, divided by 8 kilometres per litre, gives me, press the wrong button there, divided by 8, gives me 32 litres of fuel per van. And then for 6 vans, we're going to do 32 litres times by 6. So all I do, 32 times by 6. So the vans use 192 litres of fuel per day. Next, I'm going to work with the trucks. We know there's 10 trucks. One truck uses 5.5 kilometres, use up 1 litre. So I'm going to say for one truck, we're going to do 704, which is the average distance, so kilometres, divided by how far they travel per litre, so 5.5 kilometres per litre. 704 divided by 5.5 comes to 128 litres of fuel per truck. Now from there we have 10 trucks. So 10 trucks would equal 128 litres times by 10. So we can do that without the calculator. It's 1280 litres per day. Okay. Now to work out what the total fuel bill using £1.10 per litre, and to find the total fuel bill, I need to work out the total amount of fuel. So total fuel I've just realised I spelled fuel wrong the entire way around. So it's F-E, F-U-E. Thought it didn't look right. Okay, total fuel would be 1,280 litres plus 192 litres. That comes to 1,472 litres. Now we know it costs £1.10 per litre, so we're going to do 1,472 litres times by £1.10. And that comes to £1,619.20. You put the 0 on the end to have that as well. Okay. Now, in terms of my answer and adhering to this, because I've kept consistent saying litres and giving units and pound signs, that should be more than enough. I'm explaining what I'm doing as I'm going along. 1 van is this, so 6 vans is that. That's quite acceptable to leave your answers that. You don't need to write an essay for that. Just being obvious of how you're working, going 1 van is this, so 6 vans is this, 1 truck is this, so 10 trucks is this, total of fuel is that, and showing what you're doing. Not just having 1,472 pop up out of nowhere, not having 1,619.20 pop out of nowhere. Show where you're getting these wrong is more than enough to satisfy this. Okay, question 10 says Mali's scooter decreased in value by 24% in the first year. Make sure you can see the question. In all of the years, her scooter depreciated. In all further years, her scooter depreciated by 13% of its previous year's value. She originally paid £850 for a scooter. Calculate the value of Mali's scooter after 7 years. Now, this is crying for you to use something called multipliers. To work out multipliers, you always treat the original amount as 100% of the amount. In the first year, it decreased by 24%, so we take away 24% to get 76%. To use that as a multiplier, we change it to a decimal. So that'd be 0.76, because percent just means out of 100 divided by 100. That's for the first year. For all others, we're going to do 100% take away 13%. That's equal to 87%, which as a multiplier would be 0.87. Okay, so Mali's scooter cost her £850. After 1 year, it has been reduced by 24%, so finding 76% of that value would be saying times by 0.76. We would then times this by 0.87 for the second year times by 0.87, blah, blah, blah. There will be 6 lots of those in total. So the quicker way to write that is to say 850 times by 0.76 times by 0.87 to the power of 6. And that will tell us what that answer is. So 850 times by 0.76, that finds the 24% decrease, then times by 0.87, repeatedly 6 times to have it for 7 years. So I say to the power of 6, and that gives me an answer of £280.12 to 2 decimal places. Question 11, it says Sanjay stacks 3 boxes in a pile. The boxes are 25 centimetres, 36 and 47. They're all measured to the nearest centimetre. Now that word should be key when we're doing past papers. If it's measured to the nearest centimetre, it's upper and lower bounds question. It means the nearest 1 centimetre. You halve that to find 0.5 centimetres. To find the upper and lower bounds of each box, I'm going to say height here. So we've got 25 centimetres. We've got 36 centimetres, and we have 47 centimetres. To find the upper and lower bound, to find the upper bound, you would add on a half a centimetre. And to find the lower bound, you would take it off. Now, it's usually a good idea to go and find both of them. But we're asked what is the greatest possible height of all the boxes. So the greatest possible height of all the boxes would just be all of the upper bounds added together. So in my calculator goes 25.5 plus 36.5 plus 47.5. Press equals, and I get 109.5 centimetres, which is just written below. Okay, question 12. It says Ursula is lying on her surfboard, which is 180 metres away from the foot of a vertical cliff, and they've drawn that out here. They've also told me that the cliff is 146 metres high. Ursula is told that if the angle of elevation of the top of the cliff to her lying position, so we're just going to draw that in, so the top of the cliff here to her lying position here, so it makes a right angle triangle, and the angle of elevation would be looking up from the surfboard, so I'm going to call that X, so I don't know it. Should be between 42 and 45 if it is safe for her to attempt to stand on her surfboard. Calculate the angle of elevation of the top of the cliff from Ursula's body position. State whether it is safe for her to stand or whether it's not safe, she's too near the cliff or too far out to sea. So the first thing I'm going to do is call this the opposite side because it is opposite the angle that I'm looking for. The angle that I'm looking for has an adjacent side, a side next to it, which is 180, and this would be the hypotenuse side, which I don't know. I'm going to underline the opposite side because I do know it's 146. I'm going to underline the adjacent side because I do know it's 180. I'm now going to write out Sohcahtoa, and I'm going to cross out anything with an O or an A in it, so O's and A's are going. I'm going to choose Toa because it is double crossed out. I know the adjacent and the opposite. So that hopefully tells you a formula, which is tan angle, so tan X, is equal to the opposite side, so 146 divided by 180. Now, I don't want to know what tan angle is. I want to know what just the angle is. So I'm going to get the X by itself by taking the inverse of tan minus 1 of both sides. So what that looks like in effect, if you know both sides, is tan minus 1 bracket 146 over 180. Okay, now that's going to go into my calculator. So I press shift and tan, fraction 146 over 180 to the sides, close your brackets, and I get 39.0 to 1 decimal place. Okay, so that's what the angle is. Now, we know that she can only stand if she was between 42 and 45. It's not between 42 and 45. So we've got to work out now, is she too far out to sea or too close? So we're going to say not safe. Let's just think about it for a second. Okay, if I draw up here, here's the cliff, vertical, and she's really close to it. Okay, you can see that angle there would be really big if she was really close to the cliff. Whereas if she's really, really, really far out, here's the right angle. Oh, there you can see that angle is much, much, much less. Okay, so if she's really close to the angle, she's going to have a big angle. If she's really far out, she has a really small angle. This is smaller than the 42, so I would say that she is too far out to sea. So too far out to sea. Question 13. Says Martha buys a new television. She wants to fit it on a bookcase on the wall. In the shop, she forgot to write down the length of the television, but she did write down the following information, which is the screen. So if they advertise it's 44 inches, that's what they're talking about. And she knows the height there is 16 inches. Now, this will also make a right angle here. I know two sides. It wants me to find a third side. It wants me to round that to two significant figures. This is telling you to use Pythagoras Theorem, which is a squared plus b squared equals h squared. In terms of what h is opposite the right angle. I know the hypotenuse, so I'm actually going to tweak my formula to h squared take away b squared is equal to a squared. If you use different letters there, not a problem. A squared plus b squared equals c squared, fine, doesn't matter, okay? Because I know the hypotenuse, I'm going to do the biggest one squared. So 44 squared, I'm going to take away the other one, so take away 16 squared, and that is going to tell me what is the length squared, okay? So into my calculator goes 44 squared, take away 16 squared, press equals. I get 1680 is equal to a squared. I'm then going to get rid of the squares by square rooting both sides. So the square root of 1680 comes to 40.9878 blah blah blah. And to get that to two significant figures as it's requested, this is my first non-zero number, so I started counting, so irrelevant that that is 0. I've started counting, so I carry on, so second. So it's effectively just run it to the nearest whole number. So the answer would be 41 to two significant figures. We're then asked for part B. It says the television was reduced in the sale by 26% of its original price. It cost Marta £710. What was the original sale price? Now, this is very similar to what I did in the scooter question, that if you've got something that it was originally it was 100%, it's reduced in a sale, so I take away 26%, that would be equal to the price that I pay, would be equal to £710.40. 100% take away 26% is 74%. That's equal to £710.40. Sorry. Okay, so effectively that's what that was. But I don't want to know what 74% was. I want to know what it originally was. So I want to turn that into 100. The way I'm going to do that is by doing the same thing to both sides. I'm going to divide both of them by 74. That will find me what 1% is. So £710.40 divided by 74 is £9.60, 9.6, £9.60. So to find 100%, you just times that by 100. So times by 100 would tell me that it's £960. Okay? We're then told that a television uses 1 unit of electricity every 10 hours. A unit of electricity costs 9.8 pence. Calculate the cost of having the television on for 24 hours. Well, if I know that 10 hours is equal to 1 unit, which is equal to 9.8 pence, how would I go and work out what 24 hours would cost? Well, I need to know how many times 10 fits into 24. So effectively, if I do 24 divided by 10, press SD, I've times that by 2.4. So 10 times by 2.4 would be 24 hours. So if I do 9.8 times by 2.4, I get 23.52 pence. Okay? And then here it says, on average, Marta watches 4 hours of television each day. On average, how much a week? So week to days, days to weeks. So we're going to do 4 hours times by 7 is 28 hours. So it's very similar to the one above. So it's got to be more than that, because we know that 24 hours is more. So we can cross out anything less than 23.52 pence. Get rid of that. Can get rid of the pounds. It's going to be really close to 23.52 pence. So it's definitely not that or that. So it's either this one or this one. It's ludicrously close to 28 hours. So it's clearly going to be that. That's too much as far as I'm concerned. Or you could just do 9.8 times by 2.8 to work it out exactly to get 27.44. And that's just saying that 10 hours to 28 is times by 2.8. The same theory as the last one. Okay, then, I think this is the final question. No, it's not quite. I do have one after. Nearly finished, though. Nearly finished. It says, Ellen's old fish tank is leaking. The base of the tank measures 60 by 40, so let's go and write that in. That must have been 40. That must have been 60. And then we are told that before the leak, the height of the water was 45 centimetres. So that's 45 centimetres there. Okay. Ellen decides to replace her fish tank with a cylindrical one. So it looks like this, the cylindrical one. So that water is going to go into that. It says she selects a new cylindrical fish tank of those measurements which are already on there. Will all the original contents, including the water and the fish, fit into the cylindrical tank? So what we need to do is go and work out the volume of this originally. So if I do that, to work out a cylinder, to work out a cuboid, it's easy. You just do 60 times 40 times 45. You just do the length times the width times the height. We'll put that into our calculator to get 60 times 40 times 45 to get 108,000 centimetres cubed in original tank. So this tank has got to have at least that amount in there. If it's not 108,000, we're in trouble. The volume of the cylinder, so I'll say there, that was the cuboid. The volume of the cylinder. Now, you're sort of told this one in the formula sheet as well, if I can find it. Too easy if it was just there. Oh, got it. Not quite. Got it. It says volume of a prism, that's what that is. A prism is a shape that if you slice it, you'll see the same area all the time. Is the area of the cylinder, so even though I put it on its side, it'd be the area of the circle, so pi r squared, times by how long it is, times by the length. So the volume of a cylinder would be pi r squared L or pi r squared H. Those are two formulas you should know, or just one variation of that. Then we're going to do pi r squared, so pi times the radius squared, so pi 25 squared times by how long it is, so it's times by 70. So that goes into my calculator, pi brackets 25 squared times by 70. SD it comes to 137,444.6786 centimetres cubed in new. Now that's fine, there's more than enough room because it's more than 108,000, okay? So I'm just going to finish off here. Just make sure. Yeah. Yes, there is enough room. I think there's more space. I could have written that on the other side, but as I had all the numbers there, I thought that's going to suffice, okay? Over the page, and hopefully on to the last question now. Note there's another one for good measure. Two questions, the penultimate question. Quite a long paper, this one, it's not quick. Have a quick read of the question, I'll start going through it in a moment. Okay, it says Simon plans to make gloves. One morning, Simon decides to carry out a survey to find the mean handspan of people. He decides to sample systematically. He decided to sample from the first 240 people who pass him in the street during the morning. He wanted to take 20 people's handspan measurements. Explain how Simon could use systematic sampling to obtain 20 measures. Okay, so you've got to know this definition. To work that out, you do the number of people, so 240 people, you would divide that by 20. That works out as being 12. You would choose one person from every 12 that walks past. So you choose like the first person, then wait 12 people, then choose the next person, then wait 12 people. So you do it in blocks of 12, okay? So I'm going to say choose one person from of 12, e.g. 1, 13, 25, 37, and so on, okay? That's how you'd that's how you choose systematically, so you just add on 12 every time. But there's no reason why you couldn't have chosen somewhere different in the sequence, like the sixth person, then add 12, get 18, and so on, okay? We're then told this morning Simon had only managed to sample 10 people. He calculated the mean handspan of these 10 people to be 22.8. Yesterday, Simon recorded the handspans of a further 20 people. These results are shown below. Calculate an estimate of the mean of all 30 people. Okay, now this is a hard question. It's harder than normal. These are normally 4 marks. This is worth 6. Okay, but to start things off, you'd complete this as normal. Okay, there were 2 people who measured somewhere between 20 and 20.8. I don't know how much it was, so I'm going to take the midpoint of that and get 20.4. Okay, if you are in doubt with the next number, to choose the middle of 20.9 and 21.7, add those two numbers together and then divide that by 2. That will tell you the middle. That's 21.3. Okay. The next one would be 22.2, be in the middle of these two here. And in the middle of 22.7 and 23.5, you'd have 23.1. I'm now going to shade out underneath the midpoint column there. Okay. Now from here, I'm going to do the midpoint times by the frequency. 2 people had a handspan of somewhere between 20 and 20.8. I'm saying they're both 20.4. So then the total handspan measures of them would have been 40.8. Okay. The next one would be 21.3 times 3, which would be 63.9. And then 22.2 times 10 is 222. And then 23.1 times 5 is 115.5. Now I'd recommend doing that all the time because that's how you do some adding up of columns with this, but you do not add up the midpoint column. The frequency, we're told here that these were 20 people, so that adds up to 20. 5 add 10, add 3, add 2 is 20. And adding these numbers up here, I get 40.8, add 63.9, add 222, add 115.5, and that comes to 442.2. Now, the question here says, find the mean of all 30. I've got 20 people that added up to that, and we know that 10 people had a mean of that. Now, for that earlier bit of news here, that 10 people had a mean of that, we know that all handspans divided by 10, because there were 10 people, came to 22.8. So what I need to do is to work out what all of those 10 people's handspans added up to by timesing both sides by 10 to find that these 10, all of these handspans, in the original 10 came to 228. So to find the mean of 30, I want to say total handspans divided by 30 to find the mean of all of those. So that would be the 228 centimetres that added up from the first 10 people, these guys, plus from the next 20 people, which was 442.2, and then I would divide that by 30 people because there were 10 people originally and another 20. So that would be 228 plus 442.2. I didn't press the fraction button, so I'll press equals first, and then I'll divide that answer by 30. And I get the answer 22.34 centimetres. It then says, what could Simon do to improve his estimate of the handspan of people in Wales? Well, Simon's only gone to one place or one village, so he could go to different parts. Of the country. Okay? He's saying it's for Wales, but it could be that it's only in one particular place in Wales, like Cardiff or Newport or Aberystwyth or wherever. Okay? Question 16. Have a quick read and I'll start going through it, and this is the last question, so we're almost done. Okay, then it says Levi wants to attach a single strip of lights from B to A and then from A to C. The diagram shows the measurements Levi has taken after he wants to attach a string of lights. So he wants to go from B to A and then from A to C. So he wants to go from here to here. And because of these dashes, we know those are the same length. Now what's helped here is that we know that we've got a right angle triangle, that this is an angle given here, so this would be opposite it. This is the hypotenuse because it's opposite the right angle, and this is adjacent. Now, we want to know the hypotenuse, so I'm going to underline it, and I know the adjacent is 2.5, so I'm going to underline the adjacent. I'm now going to write Sohcahtoa. So, let's make sure you can see what I'm doing. Sohcahtoa. I've underlined H and A, so I need to cross out H and A. I can stop there if I wanted to because I've double crossed out Ka. That tells me cos angle, so cos 52 is equal to the adjacent side, so 2.5 divided by the hypotenuse, which I don't know. I now want to get the hypotenuse completely by itself, so I'm going to take it to the other side, where it will become hypotenuse times by cos 52 is equal to 2.5. I'm then going to get the hypotenuse by itself by dividing the cos 52 on this side. Okay, so I'm going to find out what that hypotenuse is. So 2.5 divided by cos 52 equals 4.1 to 1 decimal place. Okay, so 4.1 meters to 1 decimal place. Okay, now that means I know this is 4.1 meters and I know this is 4.1 meters because those dashes there mean they're the same. We're told that after he spends £410 at the electrical store buying a string of lights, after putting up the lights, Levi finds that he has 6 meters of string left over at one end. How much did the electrical store charge Levi per meter of his string of lights? So we know that so far he's done 4.1 meters plus another 4.1 meters and 6 meters left over comes to a total of £410. Where's my calculator? Under the paper. 4.1 plus 4.1 plus 6. We know that 14.2 meters of lighting comes to £410. Okay, I want to know how much it costs per meter, so I want to change that to 1. So what I'm going to do is divide both sides by 14.2. 14.2 divided by 14.2 would be 1 metre of lighting. And then £410 divided by 14.2 would tell me that 1 metre of lighting costs £28 and 87 pence to 2 decimal places because it's money. I hope that was useful. If it was, please hit the subscribe button and you'll get access as and when I release any other material. Thank you very much for watching.